Hi and good day to Doctor. Today our group will be presenting on our SCF assignment, which is Ionic and also Covalent crystal. Before we get started, I would like to introduce myself. My name is Alana Nabila binti Muhammad Nasir. My other group members is Nur Hidayah binti Muhammad Sukri and Nur Shafia binti Azhari. Now I will start with the introduction with the crystal meaning. Crystal is a material in which its basic components such as atoms, molecules, or ions, they are arranged in highly ordered microscopic structure, and they also arrange in a repeating 3D network, making them to have a distinct geometric shapes. And crystal can also be classified into four main types based on the type of bonding involved. And these include covalent, ionic, metallic, and molecular. And each type of different structural characteristics and physical properties. And in this our SCL, we will only discuss on the covalent and also ionic crystals. Furthermore, crystals can also be grouped according to their crystal system, and there are seven crystal systems, which are cubic, tetragonal, hexagonal, trigonal, orthorhombic, monoclinic, and triclinic. And all of these systems describe the symmetry and arrangement of the crystal lattice. And this classification helps us better understand crystal structures and their behavior in real-world application.
Now we move on to the next part, which is ionic crystal. The definition of ionic crystal is a crystalline structure that grow from ionic bonds and are held together by electrostatic attraction. The ionic crystal formation is created by the attraction of two differently charged ions, which is between a metal and also non-metal, where the metal loses electrons to become a positively charged ion, while the non-metal gains electrons to become negatively charged ion. The structure of ionic crystal is through the crystal's lattice. The ions organize themselves into a regular and repeating structure that maximize attractive forces and minimize repulsive forces between the ions, resulting in a stable solid crystal. Next is the properties of the ionic crystal. First, ionic crystal has high melting point. Ionic bonds in the lattice of ionic crystal are very strong, therefore a large amount of energy is required to overcome this strong attraction and break the ionic bonds. Second, ionic crystal has high structures due to the strong attractions between ions in the lattice. Lastly, ionic crystal is a poor electric conductor in a solid form because ions are in a fixed position and cannot be moved. However, when ionic crystals are dissolved in molten, the ions become free to move and are able to carry the electric current, allowing the substance to conduct electricity. The examples that are shared here are sodium chloride, calcium fluoride, and also lithium iodide. So that's all for the ionic crystal part.
Moving on to covalent crystal, the definition of covalent crystal are also known as atomic crystal are molecular solids in which the same or different atoms are joined together by covalent bonding. Atoms of the same or different kinds with no or small changes in electronegativity form the structural units of such crystal. The formation of covalent crystal is the continuous networks of atoms in the lattice form of connection that binds the entire crystal together as a single giant molecule. The attraction between atoms in the crystal lattice takes place as a result of strong covalent bonds formed by the sharing of electrons between adjacent atoms. The structure of covalent crystal is the atoms that are arranged in a regular, repeating crystal lattice. Each atom is covalently bonded to neighboring atoms, form a continuous 3D network, and the entire structure is held together by strong covalent bonds. Covalent crystal is high melting point and boiling point. as the covalent bonding holds the atoms together via the sharing of electrons between atoms. It possesses strong forces and hence a high amount of energy is required to break this bond. Thus, covalent crystals have high melting and boiling points. High structure because of the directional properties of the covalent bonds, and the atoms are strongly bound in the lattice and cannot be easily displaced or compressed. Lastly, poor electrical conductivity. Since the electrons are tightly held by the atoms and cannot move through the lattice, covalent crystals possess poor electrical conductivity. For example, for covalent crystal is such a diamond, graphite, and silicon dioxide. Silicon dioxide is fundamentally different from diamond and graphite because it is not a carbon-based material. Silicon dioxide is composed of silicon and oxygen atoms bonded together, forming a distinct chemical structure. In contrast, both diamond and graphite are made entirely of carbon atoms, but differ from each other only in the arrangement of their carbon atoms. Therefore, the differences between diamonds and graphite arise from their atomic structure, while silicon dioxide differs due to its different elemental composition.
Alright, now I will explain the comparison between the ionic crystal and also covalent crystal. For the similarities, both have high melting and also boiling points because strong forces must be overcome to break the lattice. For the differences, first, the constituent particle. Ionic crystals are made of positive and also negative charged ion arranged in a regular lattice. Meanwhile, covalent crystal consists of atoms bonded together by covalent bonds forming a continuous network. Second, type of bonding. Ionic crystals are held together by electrostatic attraction between oppositely charged ions. Meanwhile, covalent crystals are held by shared electron pairs, which is covalent bonds forming a giant network. Third, the electrical conductivity. Ionic crystals do not conduct electricity in a solid form, but it conducts when melted or dissolved, which is ion move freely. Meanwhile, covalent crystals generally do not conduct electric in solid or also molten form because electrons are localized in the bonds. Lastly, the mechanical properties. Ionic crystals are typically brittle due to the repulsion between the ions when the lattice is disturbed. Meanwhile, covalent crystals are often very high and incompressible due to the strong covalent network.
Next, we will look into the applications of ionic and covalent crystal. Previously, we already discussed about the comparison between both of these crystals, and both ionic and covalent is known for their hard, brittle, and also high in the melting point. Now, we will look into their application. For ionic crystal, we have a sodium chloride that used for food seasoning, and we also have a sodium bicarbonate, or known as a baking soda, used in food in our food seasoning. And sodium chloride is used also for electrolyte because its ion can conduct electricity when dissolved, which is very important for nerve and also muscle function. For ceramic, we have a dental implants and also for armor, because from this picture we can see that the green one is the ceramic, and this material are hard, strong, and resistant to heat and wear, making them suitable for the uses inside the human body. We also have the calcium carbonate that used for cement and also building because they can withstand with high heat and also the pressure over time, and making them very hard. And lastly, we have a sodium chloride and also sodium fluoride used in the supplements and also for toothpaste because they can dissociate into ions in water, allowing the fluoride ions like the sodium fluoride to strengthen tooth enamel and potassium ion to support our body functions. For the covalent crystal, we have a diamond that used for cutting tools and also polishes. And in this picture, we have the crystal structure, and diamond is extremely hard due to its strong three-dimensional covalent bonds, and um, making it very hard and resistant to scratching and also deformation over time. Next, we have the silicon and germanium that used in the semiconductors for transistors, diodes, and also the solar cells. Because uh, because they have a controlled electrical conductivity, makes them ideal for the users in the semiconductors. And we have a graphite that used in the lubricating sheets, pencils, and electrodes. While we know that covalent is very famous for its very hard, graphite is still soft because they have a weak van der Waals forces that holds the sheet together and strong covalent bonds from the sheets. And these layered structures allow the graphite um, to be soft, slippery, and useful, especially to use in the lubricants and also pencil leads. We also have the quartz, commonly used in watches, sensors, and oscillators. In these pictures, we can see the differences between the automatics and quartz watches. For the automatic, they use a kinetic energy from the wearer's wrist movement to wind a mainspring in a rotor system. While for the quartz, they use a battery system and also the piezoelectric properties, uh, that meaning it vibrates at a very stable frequency when electric current is applied, which allows accurate timekeeping compared to the automatic one. Lastly, we have the gemstone. Gemstone is widely known for its jewelry properties and also the uses in the laser technology.
Competition. In conclusion, ionic and covalent crystal are two different types of crystalline solid that differ mainly in their bonding and structure. Ionic crystals are held together by ionic bonds between charged ions, while covalent crystals are formed by covalent bonds through the sharing of electrons. These differences lead to different physical properties and determine how each type of crystal is used in everyday and industrial applications. That's all from us. Thank you.